All right. Hello. Welcome. So we are about to start now. Well, first of all, my name is Manuel Giuliani. I'm a professor at the University of West of England. Welcome. Thanks for coming. And with me is Simon Watson. And I'm using this microphone because we are also live streaming to the internet. So this is not for here. This is for the people who are online.
Hi, so I'm Simon Watson. I'm a reader in robotic systems at the University of Manchester. And what we're going to demonstrate today is a number of robotic technologies for inspection, maintenance and repair activities. We're going to start with just a bit of background as to what we've been doing, how we've got here and why this activity is important and why it's really great that you guys have been here. And then hopefully, as with all demos, you can see there's a hive of activity as various bits stop working and then start working again. So we've got 3 demos today that we'll be taking you through, most of which appear to be working now. So where we're at, why we're here. Over the last 5 years, many of you will have been aware there's major funding has gone into robotics for extreme environments through projects like RNE, so Robotics for Nuclear Environments, the RAIN Hub, NCNR, Orca Hub for offshore. And a lot of that funding is coming to the end. The hubs finished earlier this year. RNE finishes beginning of next year. And what they demonstrated, what has been demonstrated, is a lot of robotic tech capabilities. We've shown one-off missions in representative environments, but still constrained and controlled environments. And we've demonstrated that through from TRLs, say 3, 4, up to 6 and 7 for some. But the question is, where do we go from here? Because robots haven't been adopted by the nuclear industry or the offshore industry at any scale. There's still very early stages of robotic technology. You know, we haven't got robots on plants. So how do we get there from a fundamental research perspective? So what are the barriers that are stopping us? And so where we see the future, where do we want to be in 5, 10 years' time, is robots being adopted by industry on a broader scale. But what does that actually mean? What do we envisage that as being? And so our view of the future is that we will have fleets of robots operating on site, be that in nuclear power plants, fusion, fission, be that offshore wind, you know. But what they will do is they will live there. So at the moment we have a robot and you might have a team of 10 people trying to get that one robot to work, as you can see here. Whereas what you want is a fleet of 10 robots and one technician operator sat safely onshore in a nice little office area that just goes, do some missions, okay? Go do some inspections. They don't have to be technically qualified. They don't have to be have loads of training. It's a case of, right, here's a mission, go out and do it. Give me some information and I will make some judgments. So fleets of residential robots living within that asset.
Yeah, so this is collaborative work that we're doing here. So today here you have researchers from University of Glasgow, University of Manchester, and the University of West of England. But there's not today here, but there are also researchers involved from the Royal Holloway University in London, so we are working together for a while now. Simon and I are working for 5 years already, and this has been a really a great collaborationship, great friendship developing also. So what we came up with a few months ago was this idea of bringing together the researchers from all 4 universities on a weekly basis to start and collaborate with each other. And basically what we did as the more senior people, we handed it over to our researchers and they completely ran with it. The team quickly built among themselves. So we now have a remote online team of researchers working together. So all of the people you see here, they have been working together for 6 months already. offline meeting on a weekly basis, and using all of the tools that we have now available and we know how to use since the pandemic. So one good thing that came out of the pandemic. So the team is working well together. And they use all of all of the tools that are available, Teams and then online websites to collect documentation and all of these kind of things. So so basically, what you see today is the culmination of this work, 6 months of preparation, where the team got together. Maybe so around month 2 of the collaboration, this idea was born to get together. And do a 1-week event where we try and implement as much as possible based on the previous work that we have done, and then demonstrate at the end of the week. So the demonstration you see today is basically that result. So as you will see, some things will work really well. Some things might not work as well, but I think what we are able to show today is a lot of skill and capabilities and things that can come together quickly of remote working teams.
So this is a kind of a template that we're trying to establish for our future projects. So we see the development process for the next 5 years as being very much like this. The last 5 years worth of research have shown that that there isn't one single group that can do all of this. So if we look at that future vision of scalable residential fleets of robots, you need the robot, you need the human-robot interaction. So how do the operators engage with that? You need the autonomy, you need the verification, you need communication network infrastructure. It becomes a much more systems level challenge beyond, I've just built a robot, isn't it cool? And it kind of tootles around and does something. Okay, so what we've done, the 4 universities that are engaging in this have all got complementary skill sets. We're trying to bring them together in a way that doesn't often happen in academia. And one of the things that the hubs showed us is the benefit of those kind of broader collaborations. And we're trying to do the systems integration from day one. So rather than going, let's do some really cool research, and then 6 months later they go, hey, I've got 4 really cool bits of research, shall we put them together? And they don't, and nothing fits. Can we get that integration from the start all the way through? And that kind of takes us to where we are now. So for those who've never visited here, this is RACO 1. This isn't yet an operational facility. So this is a collaborative facility between Sellafield, NNL, NDA, UKAA RACE and the University of Manchester. This will go live in the next month or so. But what we're doing here is a feasibility kind of program to see what's it like actually collaborating in this space. And the idea is that you've got researchers and people from industry working side by side so that we can get more effective collaborations conducted. We can get industry input at an earlier stage, because the most successful projects we've been involved in have been user-led. What is your problem? And we can try and solve it, rather than here's a solution, do you have a problem that matches? Okay, and that never really works. So it's been a fantastic experience this week in RACO, but what's actually made it work really well is that this isn't the first time this team has met. They've been working virtually for the last 6 months together, and as Manuel said, what we've learned from COVID is how to effectively work remotely and collaboratively, which I know certain industries do really well. For universities, for academia, it's a bit of a change in our environment, so we're learning, we're upskilling, and using this as the future template.
Should we go to the demos now?
Yeah.
So just to give you a heads up of what you can see here at the demonstration today. So there will be 3 demonstrations. Demo number 1 is let me say this correctly, symbiotic multimodal fleet of robots for infrastructure maintenance and monitoring. What it means is there are robots that will monitor the pen in the middle here, to create a map of the environment and to find radiation hotspots. And so the robots involved in this demonstration, first of all, you will see a flying robot, a tello robot, and I think Dan has the robot in his hand here, yeah, or one of the robots. So this will be teleoperated by a human, and the idea would be for an operator to get a first overview of the environment. Then there will be a spot robot. This is a four-legged yellow robot by Boston Dynamics. Probably you have seen one. There's one over there. The other one will be arriving from this side, and then you will see it walking into the pen and inspecting the pen. And then we, on the images, you can already see this blue robot there. So this robot is already inside the pen. This is a Karma robot, and this robot is equipped with a radiation sensor. And what you will see is that this robot is then taking a pattern approach, so that it will do a pattern through the environment to systematically scan for radiation. You also see that on the camera there, that in the pen there's a Franca mobile robot arm. So this is used in two ways. In the first demonstration, it will be used as a, remind me then, a... Oh yeah, so that's for, it's a robot, so we call it the robot garage. Basically the idea would be that the robot can get additional sensors and additional tools from that garage. And so that's for that demonstration. The second demonstration you're going to see is a long distance operation, teleoperation from here over the internet to the lab in Glasgow. This will be then displayed on the screen here. So you will see the remote robot, and the operators will use this haptic feedback device to control the robot from here in Glasgow. And the idea behind this is basically that in order to get specialists to help with nuclear waste sort and segregation, you could have them sitting in London somewhere, and they could be connected over the internet to a robot here in Cumbria. Or from the US or wherever in the world. So that's what we are going to demonstrate live today. And then the third demonstration is, what are we going to do? The sort and segregation. So we will go back to the robot arm and show an automated nuclear sort and segregation process. The idea behind that would be that that you can place nuclear waste in front of the, or any hazardous waste really, in front of the robot. The robot is then able to take measurements of the nuclear waste and sort it into containers. All right, and just to point out, so what you can see on the screens here. So on this screen at the moment, you can see a map that has been generated by a robot. So this is a 3D point cloud, and as you can see, this is sometimes for a human not very visible, not very readable. So there's still research to be done to figure out how this kind of 3D point cloud map can be given to an operator to then make sense of the environment. So that's one thing, and this has been generated by two mobile robots that we have been driven through the pens beforehand. And then on this screen on the right here, you can see live views of the inside of the pen from 3 different cameras, and you will see that the camera pictures are quite laggy, so there will be delay, and this is down to the internet connection in here. But actually this is realistic because we expect that you don't have a perfect internet connection in most of the facilities for which these robots should be used in the future. And then on the left, you can see something very interesting. So this is a 3D model that we have created of this environment. And we use this as a digital twin. Have you heard the term digital twin before? Yeah, so most of you have heard of it. So what we mean by digital twin is this is a simulation of the environment with live input from the robots. So you will see once the robots start entering the pen, for example, you will see live data from the robots. You will be seeing the simulated robots moving as the live robots do move. And so from a research point of view, this is interesting then for mission planning and for getting a live feeling for what the robots experience. This could also be used, for example, in combination with a virtual reality headset. So the operator could sit next to the robot virtually and experience the same things as the robot. And you will also see that we are able to update information in the pen that is not in the digital twin at the moment, live on the spot. Yeah.
So before I hand over to our first demonstrator, so it's worth saying what you'll see today is a series of representative tasks. It's not a realistic task, we know that. What we're trying to demonstrate to you is capabilities, how we think things could be used, and hopefully that'll trigger some thoughts, ideas. We're open for discussions and, really importantly, feedback. So we've talked about this being a user-led process. We've taken what we've learned over the last 5 years, pulled this together. We've brought in expertise from the offshore industry. So we've got that technology transfer coming into the nuclear sector from offshore. And we've come to this set of demos today. But what's really important for us is to get your feedback. So at the end of these demos, we'd love to talk for as long as possible, or until you get bored, about what do you think about this? Where do you think the strengths and weaknesses are? How does this align to your vision of where things are going? So, yeah, I shall now pass over to Dan. I think, Dan? Okay.
So, given a quick couple minute summary of the different work packages that we've been working on as well, and that'll give a couple minute warning to everyone as well. Would you mind giving a couple minute warning to everybody? So yeah, so this is the first time that we've all met in person. I didn't realise how tall Simon was till a few days ago, and a lot of us have literally just been on Teams. So Wednesday 9 o'clock meetings are a bit grueling to get up for, but it's actually worth it when we get ourselves in here. So Sam and Subham, Sam's leading our digital twin today. He's going to be our operator from that. And then in terms of digitalisation, they've looked at everything from basic. To be honest, it's quite good when you guys are sat here. You can see everything almost that they've been doing in terms of how you visualise your robots in the space and how we get that feedback to give you guys an increased operational overview as you move on to site. In terms of other stuff we've been looking at, the wireless communications in terms of latency, bandwidth, and then of course challenges in the ideal scenario that we're in a perfect environment, but in nuclear it's a bit more difficult, especially beyond visual line of sight operations. And then for the Smurf group, has anyone made the joke yet? Nobody's made the joke yet, the Smurfs. So don't think of the little blue guys, think about symbiotic multi-robot fleets. Now, what's the difference between a symbiotic multi-robot fleet and a Smurf? The difference here is that the robots are designed to help each other. So for example, we speak about robots leveraging different capability. So you've got a wheeled robot. It's great for long-term battery for missions, right? However, it reaches obstacles in terms of terrain, stairs, other scenarios such as that. Maybe even payload capacity is quite a benefit in terms of getting components or from A to B. But then again, when we face stairs or other obstacles, we might not be able to get over other than sort of around them. So that's maybe where your Spot quadruped robot comes into play. Spot can get itself across there over different obstacles. There's different payload capabilities with Spot as well in terms of manipulator or other sensors on top of there. But then there's limitations to Spot too. Spot can't get to the high areas to inspect other aspects there. So we're trying to sort of alleviate the stress across single golden bullet ideas, let's say, and take a top-down approach to these sort of inspection missions. Okay, I think we'll probably, that's enough info, and we'll move on to the demo. if everyone's ready. So first off, what we're going to do is we're going to start off with this screen here in terms of we've got a 3D multi-mapping mission. So picture in our CAD model on the left, this is how we left our CAD model 3 months ago when you guys were out inspecting previously, and that's the previous blueprint of things. So has anything changed in the environment that we need to know about? For example, barrels, fallen over objects, it could be unidentified water. So we utilize the agile robots, which you'll be able to see a small image on the top right there. Anthony, are you nearly ready to go? Yeah? Okay, cool. So the agile robot is one of the white robots at the very top right. I'll use the mic. Oh, perfect. Thank you, Sam. And that's basically a wheeled robot with a LiDAR sensor on the top in terms of creating that 3D map that Anthony's just resetting there as well. And the point of that is to identify different areas from the initial. So what we can do is we'll compare the blueprint versus the map, and can we point out and say, this is a bit weird, we're getting a signal that's from there. Is that perhaps a barrel? Is that perhaps a wall that's fallen over and you've got a cluttered area now? So in terms of that. And then that gives us a better view. And sort of skipping on before we're ready to go. Are we ready? Yeah, go for it. Yeah, perfect. So what we're going to start doing is we're going to start teleoperating our multi-robot fleet in terms of the missions here. So what you're seeing down here, this is the pen on the very far end, which has got that sort of Minecraft pit I've been calling it, and the stairways, if Sam, yeah, perfect, the mouse over that. And then we've got our second agile robot down the bottom here, which is starting to traverse along the mission. So what we're starting to identify in terms of things that we can see, we've got the angle of the door just in here to help you guys visualize. We've got another angle on the door here. We're starting to actually build up a pretty good picture of this desk. This is where Kazong's been working for the last week. In terms of the space at the top right here, we've got the glove box with the desk coming into field of view there. And then you're starting to see the stairs at the top left there too. Not sure what's going on with this robot yet. Yeah, cool. Yeah, go for it. That's no worries. So basically, these two maps are starting to build a picture together, and that's via the point cloud data there. So I think what we're doing is we've got little boxes, each that represent where the way the LiDAR works is it's kind of like a time of flight. When you shoot the laser, and then you get a response back. And then we're starting to stitch these two together. So to be honest though, even though this robot isn't moving, we're actually starting to identify areas of clutter already. Right now, if Sam puts the mouse over the top left of the where actually behind the glove box, I never even noticed that the glove box was there. But a little bit further where the boxes are, other way. Yep, perfect. So that's an area of clutter we've got, and we can start to see that this area is already from away over here starting to get built up a picture, and that's something that has now been updated in the CAD model, which essentially is the robots we didn't use for the demonstration that are packed up in the corner there. As we look at this side here, we're starting to visualize a barrel that is represented via the shot just at the bottom there, in the very middle. So that's us representing that barrel there, and then we can actually see the outline of Karma already in this aspect here. So because Karma's in the mission scenario, we obviously know that that's the robot. And then lastly, we've got the Franca arm, which we can start to pinpoint down the bottom here, and then the second barrel, which is in view there. Now, for the next bit, I need to get David's attention so he knows that the drone's about to go scooting up in there. For the next bit, this is where we've identified these areas. I'm not sure what these areas are. I need a better view. This is enhancing the increased operational overview. So this is where Tello can be teleoperated to get the drone up to visualize that area. And I've actually lost where I put the drone, but that was oh, there it is there. Joseph, my kind assistant, can stand up and showcase the drone. Make sure you get it in the camera as well for everyone that's remote. So our tello is going to be teleoperated in a wee second, and that's to see if there is anything that hasn't been sensed, all right? Now, I know that there's a lot of sensors out there that are excellent, but cameras can still do a lot of the job for us at the same time. And even though the tello is quite a small, kind of like a toy drone, you can actually still get quite a lot of benefits out of it. All right? So I'm going to work around as if tello's going at the minute, because I think there's a wee battery issue with that, and they're going to swap the battery over. So Sam's going to teleoperate the tello from the PlayStation controller we've got, all right? Now, it's quite good. He's used an Xbox controller, so I'm not sure how he'll do with PlayStation today, right? In terms of this, what we're going to do is we're going to get a visual view of from the tello for the barrels, right? Now, we've this laid out a little bit of water, and we've put some, which is an issue there in terms of, is there a barrel that's leaking? Has it got a radioactive element to that as well? And then the other thing is if our other robots are in that area, then can these robots potentially cause more damage in this sense of spreading this liquid as well? When I think back to something that the Spot team and where was it? And I think it was Chernobyl. They took the Spot, and Spot's good because it's got a low surface contact area. So when it steps across, it doesn't move the dust around, which could be radioactive. So in the sense of a wheeled robot, that could also spread that radioactive material as well, which is something that we need to avoid. And then that allows us during our autonomous mission to also, right, we can detect a barrel here. I need to avoid that area. There's actually water over here, which is unsensed. Now Sam, our operator, has got an increased overview of that area. Right, no problem. Right, so just seeing if I've got anything else. So I think in terms of tello, we'll come back to tello. All right, no problem. So moving on to Karma, right? So Karma, I'm going to give you the acronym, right? Continuous Autonomous Radiometric Assistant, all right? Now, essentially, in summary, our blue robot, which is just in the middle of the room, that is a wheeled robot with the sensors on board are a LiDAR on top for navigation, and then we've also got a gamma and alpha sensor on the back of the robot. And then lastly, we've got a radar sensor, which we are using for water detection. So the great thing about the FMCW radar is that it's basically a point and shoot. So other traditional sort of non-destructive evaluation sensors, you need a contact measurement with it. Whereas the great thing is we can not disturb the material that we're actually sensing. With the aspect of sometimes if you touch things, no matter how delicate you can be with it, you can damage these materials as well. So when we've got that sort of stepped back view a little bit, then it improves things a little bit. So in the terms of Karma at the minute, what we're going to do is Karma is great for assessing for radiation on the ground here. So this is going to be a fully autonomous inspection using the alpha sources. Good to go?
No, we don't have Karma at the moment.
No problem.
We've got network problems. So obviously this is a learning for us from both from the modern robot fleets. We always have communication problems, so we need to work this out.
Network issues too, cool. Right, okay. So if I describe the demo of what we would have shown today, okay? So basically, we can position 5 waypoints across an area for Karma to do a lawnmower pattern to detect the radiation. And the improvement with Karma versus me doing an operation is when I'm holding the sensor to the ground, I'm probably not concentrating as fully as I should be, right? But robots are great for these dull, dirty, dangerous, and dear inspections there. So that removes the human error element there. In terms of what we would see today is basically the Karma is going to move in a raster pattern very slowly, taking an accurate inspection across this area. And then with the hope of detecting that black patch, which is our safe safe alpha emissions there. Sorry, just knocking over things. And then lastly, the other thing is, once we've detected that alpha radiation, is there any other radiation in terms of, at the minute, Karma's limited to taking a 2D map. So I can draw out on the floor and say, right, there's probably radiation in this area, but is there any radiation at height in terms of knee level, waist level, chest level, and head kind of detection there? So how are we going to rectify that? This is when we start to send in Spot for its autonomous mission. So with the Spot robot, right, I swear if we get 3 strikes here, we'll be gutted, right? Perfect, right, okay. So hopefully Spot is going to move in a wee second, all right? And you guys are going to see Spot come along. Perfect, Spot's moving, so you'll see it in a second. Right, now, Spot, this is basically an out-of-the-box robot here in terms of we've got no other additional sensors on top of it. So basically, Spot uses the Fiducial's QR codes that you can see positioned on the walls there to do its localization. So basically, when we're coming through, when Spot recognises a fiducial that it's already walked past, it can localise itself to say, oh, I remember being here, this is where I need to go in this mission. What we can see as well from the digital twin side is that the green tick is where Spot's connected, and then we've got the battery. So feel free to run that mission. So this adds to another point, right? Elements of trust, okay? Within like Manchester and everyone, there was this point that one of the that David, or the intern that's here from Sellafield, made in terms of we want robots to do autonomous inspections, right? But there's this issue regarding safety. So when do we want robots to do an autonomous mission, and when do we want a robot to do a semi-autonomous mission? So this could be an element where Spot is completing its mission, and it's for example, if something goes wrong in this mission, because we're in a safe area, this is where we can allow Spot to take control and do the autonomous inspection there, right? So that's getting Spot into the mission there. So yeah, perfect, right? Now, once Spot gets to that middle area, that's maybe where, if Spot was to do a fully autonomous inspection, several things might go wrong and be super detrimental to a nuclear facility, right? So that's where we've got Zhao Ming going to teleoperate the robot. Now, at the minute, we're just using the remote control from this point onwards. So what you've seen when Spot came in was fully autonomous, okay? And from here, we're going to use the Spot controller to, would you actually just show where Zhao Ming is, just so that we're nice and clear with everyone? He's just hiding in there. Yeah, all right. So this is where we demonstrate future capability in our nuclear analog facility, all right? So, in terms of Spot, what we've got is the Franca robot, the robot arm, which is going to complete the mission in this robot garage. So think about this robot garage in terms of how we would scale it. Picture, it doesn't have to be Spot necessarily at this position. This could be a different robot, a wheeled robot. It could even potentially be a drone in some aspects too. Sensors can be made modular. So for example, if I was the Terminator and I want to swap to something else, I'd take my hand off and swap it out with another sensor, all right? So that's what we're going to start to see with our Franca arm. So maybe if we can make this top right screen a little bit larger, and then we can play the Franca demo. So what we're going to see is at the very first black box you see on the left here, keep going left again, there we go. We have created, basically there's a gamma sensor inside this box. Now the gamma sensor was a little bit awkward to balance, hence why it's inside this box, so that the Spot arm can grab it. And the Franca arm should be programmed to go. Yeah, cool. So the Franca arm's going to pop itself down, and it's going to pick up this sensor, and picture that's a larger array of sensors there on the wall that Spot can pick and choose from. to get that sensor onto the Spot arm. Perfect. See, with the delay, that probably moved like 5 seconds ago as well. And then the Frank arm's starting to put that down, and then Xiaoming's going to initialize the Spot robot to stand up, and then move across to select that sensor. So this is the case where Spot's collecting the sensor, and that's now a payload unit on the Spot robot, and then we're going to drive the Spot round to the barrel area where we've identified some radiation, and do a more kind of accurate assessment in terms of, I guess, Z height-wise in terms of that. And that's going to allow us to understand more about, right, how long should our robots be in this area for? Can we potentially send in humans? Is there areas that we can improve this sort of map we've created of the radiation? So this is all manual teleoperation that you're seeing at the current minute, demonstrating that future capability. I guess anything else to add at the minute until Spot gets across?
Well, I mean, one thing I would add is this is actually, I mean, as I said before, this is actually a realistic simulation, really. First of all, the networking problems. Also, you don't have a line of sight to the robots at the moment, and this is what an operator would get in reality from the robot. You would either have directly, robot sensor information that you are getting displayed, or if you are lucky, there's a camera on the robot, or if you are extremely lucky, you have an external camera somewhere in the facility, and this is also not the case most of the time. So I think while it is a bit a problem with the two robots, with the first two robots that we wanted to show you, it is also a quite realistic situation here. Yeah.
Cool. So now what you've just seen is the Spot arm being teleoperated at to get these different heights with the radiation values there. And then afterwards, what the Spot's going to do is just going to turn round and then return the gamma sensor back to the designated area. And then, so there's the element of sort of collision avoidance there from the human operator teleoperating, and then there'll also be the aspect of improved situational overview in terms of avoiding that radiation area there. So Shivo, I think he's maybe getting a bit carried away. Can we get him to teleoperate back? Perfect, no problem. And then I guess in summary, in terms of everything that we've explained today, the symbiotic multi-robot fleet enables you to leverage robotic capability. So that's that thing about quadrupeds, great upstairs, agile robot. Maybe in terms of if we had one of the alpha sensors on Spot, it might not have actually worked as well because Spot kind of jumps around as it's moving through a mission. I can't believe you guys caught me on camera actually doing that. And then lastly, we're reducing risk where robots can be used via collaboration, and then enables for optimization in terms of our key focuses, which is the reliability and resilience and safety of these nuclear facilities. So Spot's now dropped off the sensor there and is going to head back out with the area back to safety, I suppose. So has anyone got any questions at the minute in terms of this demonstration, perhaps?
Have you ever tried operating Spots and the other robots remotely just using your cameras and not line of sight like you are now?
So the question, just for anyone remotely, have we tried operating the robots remotely, teleoperated, using the cameras? Do you mind actually popping back to the 3, just so we can see the whole area there? So yeah, that's one of the considerations that we with Spot was to try and have the teleoperated here in terms of, albeit there's not the wireless communications running through the DT and Wi-Fi, still showcasing that demonstration of using the arm. But in terms of the lag that we get, it's still too high to enable for accuracy in terms of getting the palm into the right place, the palm being the hand. Another thing as well is with the Spot controller, you've still got a screen in terms of the front camera, which is actually pretty good in terms of responsiveness from what you're seeing. But then again, the view, if we think about the way that we would see it and reach for something, whereas Spot it's still a little bit sketchy in terms of how Spot would view it. I don't know, Sam, this is your side, to be honest. So
yeah. So in the past, we have done Tello, the small drone, completely out of line of sight. I don't know if we got a video of that, but you would have seen it today. I was going to operate it from that screen. We can't quite see around the corner to where it is, but it's okay. It's about, I'd say roughly about a third of a second, maybe a quarter of a second delay over this distance. Our limiting factor with Tello is it's basically a toy grade drone, so it needs a direct Wi-Fi communication to the PC that's running it. Hence why that was not working right now, but it was working earlier. In terms of Spot, yeah, I think what Daniel said is completely accurate. If you're operating it through the joypad, it's pretty great. If you're trying to route it through other stuff, the latency at the moment is just too high. Yeah, in Karma, we've not got a camera for teleoperation, do we?
So, yeah, I think Kier's maybe best to answer this one in terms of Karma, actually.
Yeah, so for Karma, ideally you don't teleoperate it, it's an autonomous robot and everything does run on board the robot. So you can maybe teleoperate it to build a map or something like that, but then the idea is you leave it alone. So yeah, we don't have that issue on Karma. And I guess the more you step into autonomy and the less you rely on manual control, the less you have that issue of trying to tele up, which is really, really difficult. We did it on a different project, teleoperating a robot underground. And when you're watching on the cameras where you can observe the robot, everything's nice, and then the robot drives away and you're stuck on a little camera on the front and one on an arm, and it's a completely different game, and if there's lag or anything like that, it makes your life a heck of a lot harder. So I think it's a really good question, and yeah, something we definitely need to address in this.
Yeah, sure.
So, I mean, just to add one more point, so we have done quite extensive studies comparing teleoperation with single cameras, 360-degree cameras, and stereo cameras. And what we know from that is, so we have put those on a mobile robot, and that was the only. So in a study with I think overall 120 people, that was the only information they got from teleoperating the robot. So basically, a single camera is cheap and easy, so you can use that to drive the robot around if you are, if you're comfortable with the environment, if you know the environment. This 360-degree camera is really good because if you want to give the people a sense of awareness, so because you can stream this information to a virtual reality headset, and then people can turn around and actually have a look. So that's really good. But as soon as you want to do anything with object manipulation, so picking up barrels or picking up anything, you need to have the stereo information because so the 360-degree camera or the mono camera is not working with that. Yeah. Yeah.
So one of the things that we're doing in the next couple of months, there's a collaborative project spun out by one of the teams that's been working on the digital twin. That's going to be doing a user study on the user interface for teleoperation of robots, mobile robots specifically. And so what we're going to have is a panel that has video streams, the laser scans that you saw earlier, information like you get on a car, so a speedometer. What we've tried to do is find out what information can we get back off the robot, battery life, things like that. And then we're going to do an eye tracking study. So we're going to ask the operator to, beyond visual line of sight, control the robot to do a series of tasks, teleoperate it, and try and understand what is the operator actually looking at. Is it that they always look at the video and they never look at the 3D scan? Do they never look at the speedo? Do they not really care about that? So what information is actually useful to the operator? We're going to have the robots in Cumbria and Manchester and Bristol, and operators at different locations as well. So it will be beyond visual line of sight in that they're 200 miles away. Now, we'll be doing that initially. I think the initial plan is just to get people from our labs because that's nice and easy. We really want to do that with operators from plants. Okay, so over the next couple of months, we'll be coming to you guys and saying, right, do you have any ROV operators, drone operators, anybody who's got any type of training, and can they come and be part of a user study on this so that we can understand what does a good HRI panel look for the teleoperation. But as Keir said, ultimately, we don't want full teleoperation of the mobile robots. You know, we'd like it so that we've got some level of autonomy. So your teleoperation might be go inspect over there. Okay, I'm not going to drive you to over there, just go and inspect over there. So it minimizes the amount of training that they need, but you still have that operator in the loop. We're not going to get to the point of full autonomy where you literally just leave this robot and come back in a year's time. We're all, you know, we are assuming that there is a human in the loop at all times. May just be in a supervisory role, just making sure it's not done anything really, really stupid. But there's always going to be that oversight there.
I think we are ready to go over to the second demo.
Yeah. To the next one, yeah.
All right, so if I can draw your attention to this screen. And Hassan, do you want to come over? Yeah. So, so this is the second demonstration we have been talking about. What you can see on the screen here is a robot in Glasgow. And we are going to remote operate the robot from here to Glasgow. Yeah. And so, I mean, just to remind you, the idea behind this would be that you could, for example, ask an expert to take care of a particularly complicated waste item and lock them in from another city in the UK. But of course, this can also then could also be used with the operators just sitting outside of the room. You know, the robots being inside the room and the operators outside. So this is So this is a good demonstration. And I'm going to hand over to Hassan now to talk about the technology. Yeah.
Thank you very much. And what makes this difference from the others that we are utilizing the 5G here. Since we don't have a 5G coverage, the connection will be 4G from this site, but the Glasgow site there will be a 5G operation. And Gudong, do you want to give some more information?
Yeah, one of the challenges how can we handle this long distance teleoperation with limited bandwidth, because due to the network dynamics, or if you use wireless has the dynamic channel. So how can we teleoperate this smoothly? So the technology behind is how can we minimize the data transmission between the operator and the robot, so that the mission can be complete with dynamic communication channels or network. So that is something we are working on. And yes, today they can show the live demo.
And how can we transfer this technology into the nuclear site this technology can be used as the waste segregation. So you will see in the demo, there will be some boxes on the table. We call them as a nuclear affected or nuclear based waste, something. And the robot will be teleoperated by the haptic device you see here. So actually we are now sending some joint angle information to the Glasgow site. Now you see that is nearly real time, right? He will give some technical details about the latency and the lag between the network. Now he's going positioning. Then he will pick up the object. Yeah, since there are a lot of networks in the environment, we have sometimes have network issues because the signals are crashing on the air. And maybe we will rerun again. And since it is now stable on the table, so if we can put this onto any mobile robot and mount it. So this can be used for environments which are not explored and humans are not allowed to enter. So both using that inspection scenario and this for the waste segregation, this multi-robot team will increase the efficiency for the nuclear decommissioning, reducing the operation time, saving energy. Actually, we are now sending just the angle positions, so we want to send more sensory informations. Now we are again online, and he's going to position.
There's also some feedback here, so you can
Yeah.
touch the cube. There's also some force feedback because
Just focus on that.
directly touch the radiation waste is very dangerous, but sometimes you may feel it's what the hardness of the waste. Yeah.
Okay.
Yeah. So
You mean like this?
okay. Yeah. Yeah. So. Yeah. You can also control maybe.
He's more experienced than me. That's okay. Now he's going to pick the objects and put the objects into this box, right? Can you see? I am not sure. Maybe. Now he tries to align the grippers since there is some depth issues, right? We are facing now. We will be handling. And what the Gudong says that if we want to transmit more data, which has a large amount of data, we will need some data minimization techniques to manage the bandwidth issues. So we are just sending now the angle. Okay. We need to try again.
If you also look at the device, you will see that there's haptic feedback coming from the robot. So at the moment, the haptic feedback is the only thing that is guiding towards the object to be picked up. But as you can see from this demo, you need stereo vision, because otherwise you don't have enough depth information. So just to give you an idea, the NNL is working on a similar setup, and they use 2 big KUKA robot arms, and they have 6 cameras around the or even more. I think it's 6 cameras around the robot arranged so that you can switch between cameras and then align the robot arm this way. But so the future of this will probably be something where you have stereo vision going directly into a virtual reality headset, so that you can do this in a more immersive way. Yeah. Thank you.
Thank you very much. Do you want to add some more things, gentlemen? Please.
Yeah. So you can see during the process, there's always some sudden, movements because I touched the cube, so there's a force feedback. So this is at another dimension. When you grasp the radiation waste, sometimes you want to feel the hardness, feel it, but you don't directly feel the radiation waste is very dangerous. So you can use such kind of grippers to grasp it. Even some hand, just like your hand to toes to grasp it. So it will be more advanced in the future. So yeah, thank you. That's it.
Thank you very much. Okay. This is the end of our demo. If you have any questions.
Do we have any questions at this point? Okay. Just to point out, we are using this for waste sorting, right? But this is a kind of technology that we think could be the future for many different application areas. For example, there could be a future where you have this kind of robot in people's houses, and then there are service centers where service operators connect to the robots in the house to support someone who is maybe disabled or is older and cannot do all the tasks anymore. So this is not only for the nuclear industry interesting or for waste handling. So any remote operation you can imagine this will become interesting at some point. So yeah, I mean, you could also have this mobile. Yeah, exactly. I mean, the same arm could be fixed on a mobile robot. Yes, absolutely. And there has been so the study I've been talking about before, with the one with the where we compared the 360-degree camera, that was with our arm like this on a mobile robot. Yeah. Yeah. Yeah, absolutely. Yeah, I mean, so to the people online. So the question was if this could also be automated or partly automated. Yes, absolutely. The best approaches that are closest to a product at the moment in this area are probably where you have an augmented reality approach where the robot, because robot grasping is actually really hard and it has not been solved yet. But what is available is a human-in-the-loop approach where the robot is showing the operator how it would grasp the object, and then the operator approves the grasp, and then the robot is automatically executing the grasp. So that you still have the security and the safety involved of the operator being in the loop. Yeah. Yeah. Well, I'm not the expert, but I think it is something you would be able to service yourself, because I mean these are industrial robot arms, and they are. So I know that mostly KUKA arms are used in the nuclear industry. So there is a model available from KUKA that is very similar to this one. Also you could put these into plastic gloves, basically. Yeah. So yes, it is very serviceable. Yeah. Yeah.
So the serviceability and reliability of manipulators, they've been in use for about 40 years now in industrial manufacturing and car manufacturing plants and stuff like that. So there's a lot, they're really reliable. As you found with the mobile robots this afternoon, they're not very reliable yet, and that's because they've not been widely used. They've not had millions of hours. And one of the areas that we're interested in is, can we get them to be as reliable as this? But if you're going to remotely deploy these, you don't want to have to try and take them out. You mentioned that it's in a nuclear cell. So you put that in, taking it out is as big a challenge as getting something in. So one of the areas that we're really keen to explore in the next 5 years is, can you maintain them in situ using other robots, okay, especially mobile robots? So can we have a little robot garage that the robot goes back to at the end of its mission, where it can be maintained? You can swap parts out. Can you build it in such a modular way that you can replace the motors? But that all has to rely also on prognostics, so diagnostics. So can we monitor the robot as it's doing its mission? Can we monitor the fleet of robots? So if we've got 100 of the Karma robots operating across the NDA site, kind of NDA portfolio, can we say, right, that motor tends to break after 2,000 hours of operation, and we've had 3 cases of that. So at 1,500 hours, we're going to swap that out. And it goes back to its garage, and it automatically swaps it out. And so you don't have to take it out of the environment. You can do that maintenance. Now, that might seem super aspirational, and is that really realistic? But that's where we're trying to head to. And on the way, we will get technologies that will help that reliability in the shorter term. But eventually, you know, offshore wind is where we're really struggling on this, where if you've got your offshore wind farm 200 miles into the North Sea and your robot breaks, what are you going to do? You know, the wind turbine is much more reliable than the robot, and if you've got 100 robots out there and they keep breaking down, you can't keep affording to send somebody out on a very big boat and a helicopter to fix it. So how do we leverage the prognostics, the reliability data? How can we make the robots modular and easy to fix and automate all of that process so that humans don't have to actually get their hands dirty and you can just leave them to it?
The point cloud was generated off that robot on the floor.
Mm-hmm.
Normally, I can from one point get blind spots, don't you?
Yes.
Could you converge that with like something similar on a drone to get the buff stuff from the back?
Yes, so the question was the point cloud that we showed earlier on from the multi-agent inspection, it's going to highlight blind spots. So can we identify those blind spots and send the second robot in? And if the demo had worked, if the Tello had worked earlier, that actually was part of what we'd hoped to show. Now, the Tello doesn't have laser scanning capabilities. You know, if you've got a small toy drone, it's got a camera and that's it. But we can still identify and do visual inspections to go, is that a blank spot or is it not? There is something called the next best view problem, which is if I've got an area to inspect, can I identify where there's missing information and tell me where the next best viewpoint is so that I get that additional information? And that's where either an individual robot can do that and go, right, I've scanned this area, but I can't get around there. So either can it move or can it send a different robot? And this is where you've got collaborative robots working together. So yeah, trying to identify where those dead zones are, those, you know, lack of information is part of the challenge that we want to come so that we can get 100% coverage and get in all the nooks and crannies. Okay, any more questions before we move on to the final demonstration?
What is the resolution of the LiDAR sensor that you demonstrated before? How small is it before it doesn't get picked up by?
The resolution is 0.03 meters. That is the 3 centimeters, each voxel size. Now in this demo it's 3 centimeters, but we can change it based on our requirements easily. Is a parametric solution. Yeah.
Right, so I'm going to hand back to Dan, who's going to take us through the third demonstration. Okay.
So an interesting thing that I was looking at there actually in terms of that depth perception problem, I was looking at the shadows from the light in terms of how close I thought Zen was pretty good at teleoperating. So the next bit that we're going to showcase is the Franca arm. And I'm going to, if I open up this one, just so you guys get the best view of what's going on in this last demo. So we're good to go in terms of that one. So this is a scenario where the Franca arm represents the organisation of potential radioactive materials. So what you've seen in this one is I get to control where I'm moving stuff and where it's going to. How can we automate that process a little bit more? So in the same setup as what we had previously, we've got on the left box, Subham, if you don't mind just moving the mouse over that. In fact, the robot arm's just picking it up. We've got the gamma sensor inside the box there, and this is an automated process in terms of we've got one waypoint for the position of one box, another waypoint for the position of another box, and we're just scanning for 3 seconds at the minute here to build up a little record in terms of what's radioactive and what isn't. Once we've completed that, we pop the sensor back down, and then what we're going to do is we're going to start to sort the radioactive or non-radioactive materials here in terms of we've got a bin set up for this radioactive bit that's going in, and then we've got a safe area on the other side of the robot arm there, and then lastly we've got another radioactive place there. So how do we think about this in terms of future scaling? For example, this doesn't have to be a static panda arm here. You could have a panda arm on a rail robot here, in terms of we've got a big lineup of radioactive waste. And a second aspect of that is, this is quite a small robotic arm. We can scale up the robotic arm for a larger one here in terms of equipment-wise. And then the third component of this is, it doesn't actually have to just be the static. It could be the spot robot manipulator. In the past, I've worked with a Husky, a large wheeled robot with essentially two arms, what are they called? Universal robot manipulator arms on there as well, which has got quite good gripping capability and payload capacity there as well. And then another aspect as well is in terms of, right, what do we do now with this radioactive waste? Now it's sorted, it could be we've got a pallet robot to move it somewhere else, or even it could be movement of the radioactive and the the non-radioactive stuff there in terms of that. So that finalises that in terms of that last showcase there.
Great, thank you. So, I mean, just to add to this, this is probably the demo that is closest to the market, I would say. So, in fact, there are at the moment 5 projects that have been funded by SBRI, Small Business Research Innovation Fund, by the government, to look at exactly this problem. So we are involved at the University of West of England in one of those, together with led by Cavendish Nuclear, where we built an automated sort and segregation solution. With the goal, well, the requirements we got in this project were that basically nuclear waste is just put in front of the robots, and the robots should do all of the rest, including measuring, including characterization, including creating a list of the waste and how it has been packed. So we're working on that at the moment. There will be a demonstration later this year. Yeah. All right. So any specific questions about this part of the demonstration? Okay. Do you?
Yeah. Okay. So that's the end of the demonstrations. Of mixed success, but they've highlighted some of the fundamental issues that we really need to start addressing that have come, network connectivity, the network infrastructure is critical. And we don't have a solution to that. Part of it is going to be 5G, part of it is going to be smart use of data. At the moment where you have a single robot, you're streaming maybe a video stream back, maybe that point cloud information, maybe the sensor data. But if you have 100 robots, or even just 10 robots, we've struggled today with 4 robots. As you add more robots into your fleet, as you try to stream more data back to the operator, how do you cope with that? So what intelligent things can we do with data minimization? What data does the operator actually need? What can you rely on by storing and then retrieving at a later date? Reliability. Mechanical reliability, electrical reliability, software reliability. How do we overcome some of the challenges with that? How can we leverage learning from across a fleet? Once we've got one robot working, can we get 5, 10 of them working, and can we get that learning across? So there's many challenges across system autonomy, cyber physical architectures, human-robot interaction, robot design that we're going to try and address over the next 5 to 10 years. And we welcome as much input as we can get from end users, from the supply chain, working in either collaborative projects or saying, here are the challenges, or actually your solution isn't going to work from our perspective. Can we adapt and can we modify it? So what I'd like to do is firstly thank all of the researchers that have put in the hard work for the last 6 months, but especially over this week for putting this demonstration together. I'd like to thank you for coming and watching. We're going to open the floor now to informal Q&A questions, so you're more than welcome to go and have a look at the robots. We can go past the barrier. What I will say is please do not go into the robot pens, okay? There will be a researcher blocking you from the door. Don't make them wrestle you out of there. Feel free to have a chat to any of the researchers, to myself, Manuel. If you've got any questions, ideas, thoughts, we would welcome any of them. So thank you all, thank the researchers, and we can go for some questions. Okay, thank you very much.
Thank you.